The proximity to us, 4 light-years, is really a trifle when compared to normal space distances, played a fundamental role in making Alpha Centauri the subject of science fiction speculation, and that it was mentioned in literature and video games. The best-known example in the literary field is that of Isaac Asimov. In his cycle of the Foundation, in particular the book Foundation and Earth, Alpha Centauri is the last stage of the journey of Golan Trevize, counselor of the Foundation, before reaching the planet Land. The star in the novel is called by the diminutive Alpha, and around the main component of the system orbits a planet, in fact covered by a single immense ocean in which there is a single inhabited land, whose inhabitants are able to control the climate. From here, Trevize sets off to reach the Sun, the closest star, where it seems we can find planet Earth. In the cinematographic field, the name of this star has been widely used, especially for science fiction travels concerning galactic exploration or the immediate surroundings of the Sun. In fact, Alpha Centauri, even in reality, would be one of the very first destinations of a possible future interstellar trip manned with a human crew. In Babylon 5, a science fiction television series shot in the 1990s, the system, simply called Proxima, is one of the major colonies of the Earth Alliance. In this planetary system orbiting around Proxima Centauri, there are 3 planets, the third of which is also the largest colony in the Alliance. Over the course of the episodes, the planet declares independence, causing an interplanetary civil war. In closing of the Italian film 2019, after the fall of New York, the protagonist Parsifal leaves for Alpha Centauri. Among the films of the 2000s, there is Avatar by James Cameron, mostly set on Pandora, one of the many moons of Polyphemus, a gas giant the size of the planet Saturn, revolving around the star. In the 1960s, television series Lost in Space, a family of space settlers attempt to colonize an Alpha Centauri planet. In the DC Comics comic series, planet Rann originated in the Alpha Centauri system, until it was teleported to Polaris. In the Rann series, it is important as the foster planet of explorer and hero Adam Strange. In the world of video games, one of the most famous examples is that of the Civilization series, which places as one of the victory conditions that of sending an expedition of colonists to the Alpha Centauri system. In Sid Meier's Alpha Centauri, victory is given by the outcome of a competition between different civilizations for the conquest of the planet Chiron orbiting the star. In the various Transformers series, most of the time the native planet of the alien robots, Cybertron, orbits the aforementioned star. Science fiction and video games aside, why colonize the planets of Alpha Centauri and Proxima Centauri? First of all, for its proximity. That of Alpha Centauri is the closest star system to ours, just 4.3 light-years from the Sun. 1 light-year is the distance traveled by light in a year in a vacuum, and is equivalent to about 10,000 billions of kilometers. This means that traveling at the speed of light, it would take us 4.3 years to reach Alpha Centauri. The Alpha Centauri system is a triple system consisting of 2 stars, similar to the Sun in mass and size, quite close to each other, known as Alpha Centauri A and B, and a more distant and faint red dwarf star known as Alpha Centauri C or Proxima Centauri. The name Proxima from the Latin means closest, and in fact, to be precise, Proxima Centauri is the closest star to the Sun, which is 4.22 light-years away, and not Alpha Centauri. The brightness of Proxima is only 0.0008 times that of our Sun, while its mass is about 1/10 of the solar mass and its dimensions are smaller than that of Saturn. It is located approximately 15,000 astronomical units from components A and B. Another reason concerns the planets discovered around 2 of the 3 components of the Alpha Centauri system. We recall that to date, 2 planets in orbit around Proxima, known as Proxima Centauri B and Proxima Centauri C, are confirmed. Some time ago, the existence of a 3rd planet around Proxima, Proxima Centauri D, and 2 planets orbiting Alpha Centauri B was hypothesized, but subsequent observations have not yet been able to confirm them with certainty. As for the 2 confirmed planets, Proxima Centauri B was discovered in 2016 by analyzing data obtained through the HARPS spectrograph, mounted on the European Southern Observatory 3.6-meter telescope in La Silla, Chile. Proxima Centauri b orbits the star in just over 11 days. A year on this planet lasts as little as a week and a half on Earth. The average distance of Proxima Centauri b from its star is equal to about 0.049 astronomical units, which is less than 5% of the average distance between Earth and the Sun. Its mass is equal to 1.7 times the Earth's mass and receives only 65% of the energy that the Earth receives from the Sun. Proxima Centauri c is a super-Earth, i.e. a rocky planet like ours but a bit bigger, about 7 times more massive than Earth, which orbits around Proxima at an average distance of about 1.5 astronomical units, more or less the same distance between Mars and the Sun, taking just over 5 years. Its average temperature is about 39 Kelvin, equal to about minus 230 degrees Celsius. It was discovered by the group of researchers led by Italian astrophysicist Mario De Masso in April of 2019 by studying the small oscillations in radial velocities detected by the HARPS spectrograph. During 2020, the existence of the planet was confirmed through observations from the Hubble Space Telescope. Due to the slight differences in brightness it presents as it travels through its orbit, it is believed that it may have a ring system. It is believed that only Proxima Centauri b is located within the habitability range of its star. Recall that the habitability belt is the area around a certain star where a planet can have liquid water on its surface and a surface temperature that is neither too low nor too high, making it potentially suitable for hosting life forms. And the search for extraterrestrial life is undoubtedly one of the reasons for colonizing the Proxima Centauri system of planets. Next-generation telescopes, such as the European Extremely Large Telescope, will be used to conduct an intensive study of Proxima b in the hope of finding life forms other than terrestrial ones. Proxima Centauri c, due to the great distance from its star and the very low temperatures, is probably outside the habitability belt of its star. Another reason for colonizing the Alpha Centauri system is represented by the longevity of red dwarf stars, which is identified with the duration of the main sequence phase. The main sequence is a phase of stability in which the star, through the thermonuclear reactions that take place in the core, produces helium from the combustion of hydrogen. In the case of red dwarfs, having a mass much smaller than the solar one, the main sequence phase and therefore of stability would last longer than the entire age of the universe. And this happens because as red dwarfs have a small mass, the rate at which they burn hydrogen to produce helium is lower than for stars of greater mass. In comparison with what has happened on Earth, it is believed that life is more likely to develop on planets orbiting stars with a very long main sequence phase duration. On the other hand, however, there are some doubts that the planets orbiting the red dwarfs may actually be suitable for hosting life forms. The red dwarfs are in fact much more active stars than those similar to the Sun, and can therefore produce very intense flares associated with a conspicuous emission of ultraviolet radiation and X-rays, which can be harmful to living organisms if absorbed in high doses. These high-energy radiations investing the surface of the planets near the red dwarfs could sterilize their surface, making them unsuitable for life. It would therefore be necessary to understand if any life forms could survive in the subsoil of these planets. Another reason why the planets around the red dwarfs may not be suitable for life is the probable synchronous rotation due to the tidal star-planet interactions, which would act for the planets closest to their star. This means that the planet takes the same time to make a rotation on themselves and a revolution around the star. This would imply that one planet would always show the same hemisphere to the star, while the other would always be in the dark. Furthermore, the colonization of the Alpha Centauri system would perhaps allow us to answer, citing Douglas Adams' Hitchhiker's Guide to the Galaxy, the fundamental question about life, the universe, and everything. Are we alone? Are there habitable worlds in our galactic neighborhood? And then, after the moon, could we make the great leap to the stars? And surely the answer would not be 42, but a much more articulated answer depending on economic, political, technological, scientific reasons. And the desire to go beyond the moon is the basis of a proposal to NASA by John Culberson, a member of the House of Representatives for the state of Texas, to send a mission to Proxima Centauri by 2069. The date is not accidental, but it would fall in the centenary of the conquest of the moon. It must be remembered that scientists continue to discover exoplanets using powerful orbiting telescopes, but we physically have moved very little from the Earth. Only the Voyager 1 and Voyager 2 missions, launched in 1977 and containing a disc with the sounds of the Earth intended for any extraterrestrial listeners who might come across the probe in a distant future, have recently crossed the boundaries of our solar system. For this purpose, one cannot fail to mention the breakthrough initiatives announced in July 2015 by the Russian tycoon Yuri Milner. It is a scientific program aimed at searching for signals coming from space and sent by any extraterrestrial civilizations. It is divided into 3 projects: Breakthrough Listen, whose idea is to obtain the spectrum of about 1 million stars in search of possible non-terrestrial signals of artificial origin, and Breakthrough Message, which will have as its purpose, in case the listen phase, they're allowed to discover extraterrestrial civilizations to send them a message. The third project, Breakthrough Initiative, is perhaps the most interesting. Announced on April 12, 2016, it was born with the intention of developing a prototype of laser-powered light spacecraft called Starship, capable of traveling up to the Alpha Centauri star system at a speed between 15% and 20% of that of the light in the vacuum, thus taking 20 to 30 years to reach it and about 4 years to notify it to planet Earth. In addition to Yuri Milner, the project initially included Facebook founder Mark Zuckerberg and late British astrophysicist Stephen Hawking. It is believed that at least 20 years are required for the realization of the project. The Starshot concept involves the launch of a mothership that carries small spacecraft the size of a few centimeters to the outside of Earth's orbit. From here, a laser beam coming from the ground will accelerate the 4 by 4 meter sails connected to the microprobes up to 100 kilometers per second squared. Thanks to these probes, it will be possible to reach and visit the planet Proxima Centauri b in about 30 years and capture an image of high quality sufficient to fully understand the surface characteristics of the planet. A swarm of about 1,000 units is assumed to compensate for the losses caused by interstellar dust collisions while navigating to the planet of interest. In a recent detailed study, astrophysicist Chai-Tem Hong and his collaborators found that mitigating collisions with dust, hydrogen, and cosmic rays may not be as serious an engineering problem as one might think.